My name's Jenna. Welcome to the Computer Science and Engineering Department here at UTA. Throughout this video, you'll see various UTA objects hidden in the video, UTA Easter eggs. Keep track of where you see them because after you watch the video, you can match the objects to where you saw them on campus and receive virtual raffle tickets. Every ticket you earn gives you a better chance at some great prizes. We are currently in the Engineering Research Building, otherwise known as the ERB. Let's go look around. Let's go check out a classroom here at the ERB. Let's go check out the 6th floor. Welcome to the 6th floor of the ERB. Here's the photo wall of all of the CSE faculty here at UTA. You should be able to find almost any CSE professor you have. Let's go check out the CSE department office. We are now in the CSE department's office here in the ERB 640. If you have questions like, I can't find my classroom, or where's my professor's office, or even, I don't know my professor's office hours, you can find the answers right here in the CSE department's office. Now that we've checked out the CSE office, let's go find the advisors' offices here in the CSE department. And there's Netterman Hall. You might have a lot of your classes there in the future. Right here, this green area is actually the engineering quad. It's a nice place to hang out when the weather is good. There's some picnic tables down there, and they even have plug-ins to plug in your laptop or your phone, whatever you need to study down there. Here we are at the CSE advising offices. Let's go take a look. First, we have the graduate advising offices. Here is Miss Shalonda Towns. She's a staff advisor. Then we have Miss Ginger Dickens. She's also a staff advisor. Soon we'll have our newest staff advisor, Morgan. Here she'll be around this area at some point. Let's go on to the faculty advisors. Here we have Dr. Khalili. And then we have our newest faculty advisor, Donna French. Let's go check out the undergraduate advisors now. Right down the hall from the graduate advisors, we have the undergraduate advisors. First, we have a staff advisor, Katie Padone. Then we have the second staff advisor, Miss Melissa Rose. Then we have one of the undergraduate faculty advisors, Dr. Linda Barash. Lastly, we have Dr. Chris Conley. He's another faculty advisor. Here in the undergraduate advising area, we have this really awesome bulletin board that has a lot of information that you might need. Then, there's also a really great view that you can see Cowboy Stadium all the way from here. Next, we have the iSec lab here at ERB 316. Let's go check it out. Welcome to the Information Security Lab here at UTA, also better known as the iSec lab. Today we're here with Christian and Ho Tian. They're going to tell us a little bit about the lab and what they do here.
Yeah, welcome to our lab. As the name suggested, we are the Information Security Lab. And we do like the malware analysis and utilizing the binary information and also the hardware information. So we do lots of something like using the program hunter in the CPU and to do to analyze the malware behaviors. And our lab also we featured the information security lectures. So down in the 106, we also have the information security lab to perform the buffer overflow attacking and such of things. We are welcome you to UTA, and if you are happy with binary analysis or malware analysis, you're welcome to come to our lab and discuss with us.
All right. Thank you guys so much for telling us about the iSec lab.
You're welcome.
Let's go check out the VLM lab. Let's go. Welcome to the Vision Learning Mining Research Lab here at UTA, or the VLM lab. Here we're with Reza, and he's going to tell us a little bit about this place.
So we're at the VLM lab, as you said. This is on the 3rd floor of ERB and is the home to technologies regarding computer vision. Computer vision is a sub-area of AI, which corresponds to the technologies about images, analyzing videos, analyzes images, like face recognition of the phones. That's a very good example of that. Self-driving cars, these are good examples of computer vision. You have to see the road with cameras. And we do research. People talk about labs, they think about very technical labs, like chemistry, biology labs, but it's basically a computer lab here. So yeah, this is it from our lab.
So what kind of students are usually in this lab?
So we have a combination of master's, PhD students, and sometimes occasionally undergrads are here. Because it's a computer lab, some people do it remotely. They can connect remotely to these computers. And yeah, so these are very strong computers with some strong processing powers that are not your typical computers at home usually. So we use the benefit of their power.
Awesome, awesome.
They have good graphic cards because what we're doing, we analyze with images and videos. It needs strong processing power.
Awesome. Right. Thank you so much for telling us about the VLM lab. We appreciate it. Our next lab on the list is the Robotic Vision Lab. It's here in ERB 413. Let's go check it out. Here we are in the Robotics Vision Lab here with Chris and Nolan, and they're going to tell us a little bit about their lab.
So in the Robotics Vision Lab, we tackle a lot of topics that have to do with robots and computer vision. So there could be a large number of topics that can kind of fit into this realm. So for example, one of them that we tackle is called Next Best View, which is when a robot looks at an object, how do they know that that is the object they think it is? Normally, for a human, you would look slightly differently at a different angle to see what it is. So that's next best view. How do we tell a robot where to look next to understand what an object is? That's just one of the many problems that we kind of tackle in the lab. Nolan, do you have any more?
Yeah, so on the software side, we've tackled super resolution and object detection. For super resolution, we're actually using neural networks to make images that are low quality or high quality. And for object detection, we've been focused on probabilistic object detection. So that's just having models that can have more quality predictions about images.
All right, would you guys like to show us around the lab?
Absolutely.
Let's go.
So we have a lot of really cool tools that students can use when working on the research, and this is one of them. We're still building it, hence why we have all these unopened boxes. But this is a Husky robot, and it is meant to go into an agricultural field and get data on various crops and their conditions and diseases that we might see visually. So hopefully in the future we can have autonomous vehicles that drive through these farms and can recognize problems so the farmers can tackle them earlier on. So this is one really cool tool. We also have full virtual reality setups. If people want to work with robot simulations in virtual reality, that's a big one. We have 3D printers, electronic kits. We build our own robots here. This guy has been in quite a few projects. He has seen a lot of use. And so yeah, in this lab you can definitely just be yourself and experiment and learn how to build these robots and work with them yourselves. So this right here is a UR5 robotic arm. This is brand new, we just got this. And we're planning on using this for picking and placing of various objects and recognizing in space. So, for example, so it can do a whole bunch of stuff. It can't just pick up cans. Hopefully we can teach you to do more than that. But this just shows the number of robots that we have in the lab that all the students can use for anything that they really want to. It's pretty open. We have another fetch robot in the corner, which actually can move around and has an arm. So we're hoping to find great uses through robotic vision. into how to solve just a lot of the problems that are showing up with the increased use of robotics in daily life.
All right, well, thank you, Chris and Nolan, for showing us around the Robotics Vision Lab.
You're very welcome. You're welcome.
Let's go check out the Hybrid Atelier Lab here at UTA. This lab is hosted by Dr. Torres. He's going to give us an awesome tour. Let's check it out. Welcome to the Hybrid Atelier here at UTA. This is Dr. Torres, and he's going to give us a tour.
Hi everybody, welcome to the lab. This is a creativity research makerspace here on campus that was just started about a year ago. One of the things that we do in this lab is research in physical computing. And so that really is involved with understanding how computers can both sense our environments as well as change them. So we have here a bunch of different digital fabrication equipment to help us realize some of these ideas. Over here you see state-of-the-art equipment for making SLA 3D printing. So this uses a UV light to cure resin into physical forms. You can see some of the forms that the lab has made over the years. Every member of the lab has to create a 3D printed effigy to protect them against the failures of different 3D printing devices. Here is a print that was actually made using a wax resin. And so these are really important for us to work with different materials. And that might actually be a good leeway to show you this space behind you. One of the things that we're trying to expand on is the future of digital fabrication. And so this means working with materials beyond plastics. So in this lab, we have all the equipment to work with clay. Over here, you'll see a clay 3D printer ready to go. We have different materials here, machines here for working with woods. And then we have industrial kilns for being able to create some of these ceramic forms. So that print that you saw over here is actually part of the technique for creating and using 3D printing inside and using a lost wax technique to create forms within those kilns themselves. Further along, we have a laser cutter like you might expect from any makerspace that allows us to create really custom and refined shapes in different types of plastics. We also use it to cut fabric. So a big element of what we do in the lab here is in e-textiles. So if you walk with me over to this space, I have a little demo for you. This is a prototype that we made with a visiting artist from Swarthmore College of Art and Design. So one of the really interesting materials that we have available to us is conductive thread. And what that allows us to do is to embroider a thread-like material that is actually conductive to electricity. And so when I press this button here, what you see is this circuit supplying electricity to this part of the glove, and you'll notice that it's changing color. We silkscreen a liquid crystal material that allows us to control the expression of color on a garment. And so we're using this technique to create non-emissive displays on our clothing, to imagine interfaces that move beyond the screen and onto our actual clothing. So a big element of this lab is understanding human-computer interaction. And so that is looking at how computers and humans can interact with each other in productive ways, specifically in the realm of creativity. We have a lot of equipment for working with glass. This has been one of the most recent projects within the lab, trying to understand how we can use sensors to understand audio activity. For example, how might a microphone detect when somebody is grinding glass and give them feedback to support them in those types of processes? Another area of the lab is around casting and mold making. So here we have all types of materials for creating resin, silicone, and even rubber molds. So I'll show you some prototypes of what that looks like over here. Here we have our textiles forming station. So we have our standard sewing machine, but it also is allowing us to interface with these electronic components. So this is an example of a class project that we had just recently. What it is a continuity checker. So whenever these two pins touch each other, it turns on this LED. It completes a circuit. And so this is a tool for understanding whether or not there's electrical connectivity in different types of garments. So if we look at this garment over here, you'll notice an embroidery pattern and different pieces of conductive thread that are hanging off here. So I can check to see, is this conductive thread actually working? Where does it travel to? Where in this garment does it live in? And so part of the reason we create these tools is to interface with different types of textile materials in ways that multimeters and current types of electronic prototyping equipment just can't do. So ubiquitous computing is this idea of mixing the computer into our environments to the point where we don't even realize that computer is there. So here we have an IoT microphone. So this is a microphone like you might imagine on your earbuds or any type of consumer electronic, except it moves around the lab. And what we can do with it is actually detect different types of audio activity. So for example, as I bring it close to my face and start talking, I can use it as a voice interface. If it's next to one of those noisy machines, I can use it to characterize what we're doing with those different machines. So it's a way for us to create these smart interactions using data from the environment, but not being constrained to a specific infrastructure. It really is about mobility in these specific scenarios. We can also control this is the law of the demo, too. So here, this is also being wirelessly communicated with. This is just a normal LED, but it allows us to test different types of expressions without having to reprogram a microcontroller. So it's thinking about new ways to code these types of electronics without having to go through these tedious compile and upload cycles. We also have really standard types of equipment for working with vinyl. So this is a vinyl cutter. One of the ways that we use this is to cut different types of shape to be used in a silk screen press. Some of the newest materials use this age-old technique in art practice to be able to lay down electronic traces. So we use conductive silver or liquid crystal and lay them directly down onto different types of fabrics. So for example, this one has been screen printed with liquid crystal, and so my body heat is causing it to change color. We may need a glow torch. So this was made using this technique here, laying down different types of materials. And then lastly, we do some woodworking. So we have this standard equipment for us to prototype different wooden forms. Now you may be wondering what's happening in this space. One of the things that makes us so distinct from other types of labs in computer science is we do human subjects research. So we often bring in user participants to try out our tools and the things we develop in this lab. And this is a space for us to have conversations with them, to better understand how technology can really enhance and interface with our society as well as our culture.
Thank you so much for the tour, Dr. Torres.
Absolutely.
If you have any interest in looking into how humans interact with technology, be sure to check out the Hybrid Atelier Lab.
All right, thank you. Take care, everyone.
Now we're going to visit the Senior Design Lab here at the ERB. It's located in ERB 208. Let's take a look inside. Welcome to the Senior Design Lab. This is Dr. McMurrow, and we're going to answer some questions about the Senior Design Lab.
Sure. So welcome to the Senior Design Lab. This is where we do our 4316 and 4317 course sequence, Senior Design 1 and Senior Design 2. So in those classes, we have teams of 5 to 6 students in computer science, software engineering, and computer engineering. They work on multidisciplinary teams, and they work on all sorts of different projects ranging from robotics to electronics to mobile apps, software, AI, anything you can imagine.
All right. Would you like to give us a tour around the lab?
Sure, come on in.
All right, let's go. Go ahead, I'll just follow you.
So we'll start over here. In this lab space, we have room for 20 teams. So each team gets their own area. Some areas are kind of shared, but everybody has at least some workspace. There's always all sorts of activity going on in here. So you can see there's like plenty of parts out and plenty of things being sort of actively worked on. This is a UR5 industrial robot. This is actually a really impressive co-robot. So it's a legitimate industrial robot. It can move very accurately and it can move very quickly. This robot is special because normally, like in a factory, you'd have like fences and stuff to keep people away from the robot, to keep them from getting injured. This robot can actually sense if it's making contact with someone, and it can stop immediately. So it's a really neat project. We do things like chess playing robots. We did a recycling application where we were using computer vision to find different types of recyclable plastics and to sort them into bins. So we do all sorts of different logistics and supply chain and industrial type projects. And if we move along in here, we have a small prototyping and MakerSpace. So here we have different kinds of 3D printers. These are Ultimaker FDM fused deposition modeling printers. So these are like your typical 3D printer that squirts down hot plastic and builds from the bottom up. We also have a Formlabs stereolithography or SLA printer. This actually prints in resin, and it prints these really high resolution models. So this is kind of cool because it sort of pulls the model out of a pool of UV resin and it builds it from the bottom up. So this works by, it's got a little ultraviolet laser on it. The little laser goes around into a little pool of ultraviolet cured resin material, and it turns that liquid material into plastic from the bottom up. So this is a little bit of a slower process, but it's much more accurate. You can also print in different engineering plastics and different engineering compounds. You can do like dental grade orthodontics, for example. If you wanted to print like a retainer or something like that, you could actually do that on this printer. You can do like flexible materials, heat resistant materials, all sorts of different stuff. So you can do a lot more interesting material science projects with this type of printer than you can with these. But these are kind of our workhorse. We can do mounting brackets, plates to carry electronics, different kinds of enclosures, and all sorts of stuff like that. We have an electronics prototyping area here. Most of the equipment is put away in the cabinets, but we've got surface mount soldering capability. We have all your typical bench electronics like multimeters, function generators, all that kind of stuff. And then here we just have general part storage. We maintain kind of on hand all the different cables, chips, wires, cameras, all sorts of different things that we need to do these projects. So it's a really fun course sequence to be in. It's a 2-semester back-to-back series, so you get to work on a really exciting project for 2 whole semesters with 4 or 5 other students, so it's really interesting. And then I'll take you around here to the lab space. You might see some different projects that are being worked on right now. So these are mostly software projects. Over there, it looks like we have a project involving, those are like laser tag guns. So I think we have a team that's developing like a smart app that connects the phones to the laser tag guns so they can like use GPS and have a more kind of like immersive experience. So a lot of different interesting stuff like that going on. Toward the back, we tend to have sort of our bigger, sort of dirtier projects, I call them. So a lot of ground robotics and things like that. At the moment, let's see, there's I'm familiar with about half of these projects. So that is a augmented reality sandbox. What that does, there's a 3D sensor that points over the sandbox, and it's a physical sandbox. You can actually find the sand in there. And that will measure the contour of the ground, and then it'll shine a projector over it to render like a 3D scene, like a volcano or something like that. Sort of something you might see in like a hands-on museum, that sort of thing. These are various projects from like older ground robots we've got. A rocket launching station. We had a like a sensor package that went in the nose cone of a hobby style model rocket. Had like an altimeter, airspeed indicator, all that kind of stuff. So all sorts of different things going on here at any given time. And you can see just looking around that there's a lot of things that are half completed because we're right in the middle of the semester. So toward the end of each semester, you'll start to see some really interesting functional things start to come out. So.
All right, that was a great tour. Thank you so much.
Thank you.
Eventually, when you end up here, you'll be making some really awesome things. This lab has 24-hour access, and I'm sure you all look forward to being here. This is a really cool part of the quad. It's like this little rock garden area. All right, Netterman Hall time. During the Christmas time in ERB, there's a competition where they put up Christmas decorations on all the balconies. Here we are in front of the Netterman Hall. Here's one of the entrances to Netterman Hall. Let's go in. Here we have one of my favorite rooms. The Hall of Flags. Fun fact, every single flag on here represents a country that someone is from in the engineering department. Anytime a new student in the engineering college comes in from a new country, they put up a new banner with the new country listed on it. Let's go look at one of the bigger classrooms here in Netterman Hall. Here's Netterman Hall 100. Not only classes are held here either, there's actually a lot of events that take place in Netterman Hall. And now here we are at Netterman Hall 241 in the CSE and Electrical Engineering Makerspace. Back with Dr. McMurrow, and he's going to show us around. Go! Hello again.
Welcome.
Alright, show us around. Give us the lay of the land.
Alrighty, so this is the Computer Science and Electrical Engineering Makerspace. This is basically a space for making whatever kind of stuff it is that you want to make. It's a joint sort of venture in the College of Engineering. Any of the engineering students within the college are welcome to come and access this. We have open hours in the afternoons. The schedule fluctuates a little bit based on demand, but typically after noon during weekdays, you can come in here. You can also request 24-hour access, just like the other lab spaces. So you would need to send me an email with your full name and your student ID, and basically we can get you trained and get you access whenever you want. So I'm going to kind of show you some of the different areas. We specialize in a lot of different things here, and we have a lot of different awesome pieces of equipment. This is actually my favorite place on campus. You can just do so much work in here, and it's actually kind of quiet. So sort of in this corner and going along this wall, we have electronics prototyping equipment. So we have all your normal multimeters, function generators, oscilloscope type stuff. We have some RF equipment, some really nice kind of like high-end oscilloscopes and things like that, and function analyzers, signal generators. So all that sort of runs this way. We have several stations with that kind of equipment available. So if you're doing any kind of electronics work, all this area is open for you. You move over here, and we're still kind of in the circuit sort of part of the lab. We have surface mounting equipment. So these are hot air rework stations that also have your normal sort of soldering irons on there. So you can actually do professional grade surface mount PCB printed circuit board work in this lab. It's really pretty cool. So one of the things we often will do is somebody will design a board. They'll have it fabricated at a board shop, like some online places. They'll get the board in, they'll have to solder the chips on there. And with this hot air station, you can actually do like very intricate chips and get really professional looking results. So we have all that equipment. Kind of moving on, we've got some higher end items over here. This is an automatic pick and place machine. So this allows you, if you wanted to make 100 boards or 1,000 boards in one run, this is an automated robotic pick and place machine. So you can have your printed circuit boards, you put them in here. There's a camera system that'll go and pick up each chip and align it. and then go and drop it down onto the board automatically. And then you can put all your boards into an oven to bake the solder onto it, and then you basically have a large batch of boards. So hypothetically, we can do like large quantities of PCBs here. We have that capability. Moving on a little bit, I'm going to skip this one and come back to it. This is it's called a Vision Assist manual pick and place. So what this does is, if you are trying to create a circuit board like this, you'd order this from a website. So you'd have your design, and then you'd be ready to basically solder your chips onto there. You put your chips over here, or your boards, into the machine, and there's a camera system that actually looks, and it allows you to use this joystick, and you can go and pick up like a very intricate chip or circuit element or whatever it may be, and lift it up and do a controlled drop with these high precision cameras that are looking at it. So you can basically make sure that the chip doesn't sort of like rock back and forth, and do a controlled drop and get a perfect placement there. It's a lot better than using like, say, tweezers like you would use over there to place a chip down. You can do much more accurate placement, get much better results, far fewer errors. So this is a really nice piece of equipment that we have, and it's there for making circuit boards. This device over here, this is a vacuum forming machine, a thermoplastic vacuum former. So what this does is it takes flat plastic sheets like this, you load it in the machine, and you put your whatever object it is you want to clone. So you're basically making a vacuum form model of it. So you put your object in there, you put the sheet in, the sheet goes into the heater, it warms it up, it starts to droop, it becomes a little bit, it starts to flow a little bit. And then you bring it over here and you crank this knob, and that will lift the model up into the molten plastic and make you a copy. So for example, this was like a race car body that we made. This is just like a toy race car or something like that. You put the toy race car in here, you put the sheet in there, crank this down, and then you're left with a model like this. Now this is cool because you can make like, let's say you're working on a drone and you need to make like a cowling, like a covering for your drone. You can do that kind of work in here. Let's say that you're working with maybe ceramics or like plaster of Paris or carbon fiber resins or something like that. You can make essentially a mold for those other types of materials. So you can basically use this plastic, which is really cheap, as your mold, and then you could do your carbon fiber work in here, and then you can throw the mold away and you're left with a carbon fiber shell. So you can actually do some really interesting stuff with a piece of equipment like this, and it's really cheap to use. The sheets there are, 5 or 10 cents a piece or something like that, maybe a quarter. Okay, so let's continue going this way. We have possibly my favorite piece of equipment on campus. This is a large format CO2 laser. So this allows us to cut woods, plastics, rubber, some other types of materials as well. So we do a lot of plastic work. So for example, this is a relatively cheap acrylic from like, a local home improvement store. And we can very quickly cut out whatever kind of shape you want in 2D. Now, this is a two-dimensional machine, so you're not going to be able to do like a three-dimensional structure like you would with a 3D printer. But you can cut out 2D shapes that are very rigid, made out of really cheap material like wood, medium density fiberboard, acrylic, whatever. And we can do that really fast. So like each of these little objects here that were cut out, you can cut that one of those out in maybe like 10 seconds or something. So if you're making a high quantity of little small parts or anything that's flat, you can basically do that kind of fabrication very fast. It's really pretty convenient. Okay, we have design computers for all the different machines we have. Here we've got 2 of the SLA resin 3D printers. Those are the high precision ones where you can do like different types of materials and very intricate high fidelity models. And then we have a bank of Ultimaker S5 fused deposition modeling or FDM printers. So these things are awesome. You can see they're used pretty close to 24 hours a day. So we have 8 of them right now. These are Ultimaker S5. These are basically like the Cadillac of 3D printers. They're very reliable. They make really good printing results. We have different colors loaded at all times. We can do different types of materials in these. We typically will do PLA. So we maintain a big stock of PLA 3D printer material, and a lot of that is paid for by some grant money that we have. So a lot of the material in here, if you're not using huge quantities of it, it's free. It's available for you to use. That applies to a lot of the expendable materials like the woods and plastics and the laser cutter, 3D printer materials, and so on and so forth. So these get used far more than anything else in the lab. We're just constantly generating different parts for all sorts of different projects. And I'll take you over here to this corner. This is sort of the dirty corner of the lab. This is where we use equipment that might generate sawdust or metal shavings and things like that. So you have your typical sort of shop equipment. You got band saws here, you got a drill press. These are just like manual drill presses where you plunge a drill down into whatever it is you're trying to cut. We have circuit board cutting mills. These can do double-sided copper-clad boards if you want to cut your own circuit board here. So normally when I make a circuit board, I'll do my design, I'll order it from somewhere, and I'll wait a week or two, and then I'll get the board, and I'll come here and I'll solder it. But if your design is not super intricate, if it's relatively simple, you can actually cut it directly out of the copper right here, and you can have a circuit board made the same day, like an hour later. So this is a really nice capability. Our electrical engineering students use these things a lot. They're pretty good, and they generate some pretty good results. This is a 2D wood and plastic router. So you can do 3D designs in this. It moves a router around and will actually cut whatever material you're trying to build. So you can do like different kinds of models. You can do 2-dimensional designs or 3-dimensional designs as long as the geometry is kind of compatible with this. So this is a Sheipoku, pretty common CNC router that's available. And then over here we have our sort of machine shop style equipment. This is a really nice 3D CNC machine, a 3-axis machine. So here you can do metals. So this machine can handle steel. We only cut aluminum and brass with it right now, but if we have a special project, we potentially could cut some steel, but typically we just cut aluminum here. This is a wood test that we did. So basically you can take a block of raw material, wood, aluminum, steel, whatever it may be, and you can do your cuts in here. So it's a subtractive manufacturing process. But this is a really nice CNC machine. We have a manual version of that. This is a manual milling machine. So you can actually do your cuts by turning all these knobs. If you need to do some kind of simple geometry, like cut a slot into something, you can do that here. We have a manual lathe. So the lathe allows you to cut things longitudinally. So if you have like an aluminum rod in here, or like imagine you want to make a baseball bat or something like that, you could do that sort of work on a machine like this, where you spin the piece and then you cut into the side. And we have a larger bandsaw, and there's some kind of projects sort of in the works over here, but we also have a lot of different pieces of equipment, like there's a microwave, there's a dehydrator, there's some other things that kind of look like cooking equipment. It's not for cooking, it's because sometimes we make cure different materials. For example, we had a project where we were making drones out of bacterial cellulose. So we literally were growing kombucha, like bacterial cellulose in here. Sounds really weird, and it was a weird project. But we were using that material to actually make drones. That was with a US Army sponsored project that we competed in, our students competed in. So we were growing that material in the bioengineering department. We were bringing the material over here, and then we were curing it and building drone bodies and all sorts of different stuff out of it. And we were using dehydrators and different kitchen style equipment, a blender, microwave, all that sort of stuff. And that's about it. There's a lot of open working area right now because of social distancing. There's a lot less chairs in here, but normally there's a little bit more tables and kind of more activity going on. But you come in here sort of any given time, you'll see the 3D printers humming away. There may be somebody using a laser cutter. There may be someone over here using different kind of machine shop equipment. It's a really exciting place to be.
All right, thank you so much, Dr.
Thanks for coming.
McMurrow. On our way to the zoo, let's check this out. This is the symbol that represents the Engineering Honor Society here at UTA. Here's another building you might have some classes at. Science Hall. Here's another stop on our way to the Sear. This is the Central Library. Fun fact. It's really cool to see in the winter. This fountain actually freezes over sometimes, even in Texas. SEER stands for for science and engineering, innovation, and research. Now that we're here, let's go check it out. Let's go check out a SEER classroom. They're ginormous. Let's go check out the upstairs. They've got little individual pods for studying. Let's go check out the view. It's a great view. Thanks for joining me on this virtual tour of the Computer Science and Engineering Department here at UTA. Let's have a really great semester, stay safe, stay healthy, and map up.